Today we're in section 7.4, solving equations using multiplication and division. This is very similar to adding and subtracting. It's just we're still using those opposite operations to get the variable by itself. So in example 1, let's start off with 4x equals 60. All right, well, clearly by the title of this slide, we know that multiplication is the operation that's connected to our variable. Everybody agree? 4x next to each other, that means multiplication. So what's the opposite of multiplication? Division. So in order to get x by itself, I have to divide by whatever number is attached to my variable. So I divide one side by 4, that gets x by itself. But my rule is whatever I do to one side, I have to do the same thing to the other side. So 60 divided by 4, and you can use your calculators if you need to, 60 divided by 4 would be 15. 15. All right. 60 divided by 4 is 15. X equals 15. All right. And then you can check it just like normal. Okay. You can plug 15 back into the original. Is it true that 4 times 15 is 60? So you would say 60 equals 60 and it checks out. All right. You try to do the second one. Solve and check. Divide both sides by 2. Very good. I want you using the fraction bar. Do not use the division symbol. Use the fraction bar underneath the term with the variable. Showing your work is very important. Okay, if you don't show your work, you're not going to get credit on your homework. It'll be counted wrong. All right, so then x equals, and I heard the answer, 28. X equals 28. Now we just go back and we plug it in. 2 times 28 is 56, and yes, that's true. 56 equals 56. And it checks out. All right, now let's do some more. Okay, now I have negative 3a equals 63. So anytime I have a negative number that's attached to my variable, I have to make sure that I take it with me, that I divide both sides by that negative number. I cannot leave the negative with the variable. The variable can't be negative. So if I divide the left side by negative 3, you're writing this down in your notes, right?
Yes, ma'am.
Then I need to divide the other side by what? Negative 3. Well, what's 63 divided by negative 3? I heard it. Negative 21. Why is it negative 21?
If you multiply both, one's odd. So
Okay, there's an odd number of negatives. So A equals negative 21. And then I check it the same way. Okay, negative 3. I'd say negative 3 times 20. Negative 3 times negative 21 equals 63. Okay, well, now it's a negative times a negative. That's 2 negatives, so that'll be a positive 63. So it still works out. 63 equals 63, and it checks out. All right, now let's look at this next one. Well, this one's different because there's no number with the variable. But what do I know about a variable that doesn't have a number in front of it? There's an understood 1. So whenever you see this, and you'll see this on your homework tonight, I want you to just write in an understood 1 in front of the variable. Now, I mean, it seems kind of simple, but what do you need to divide by to get x by itself?
1.
Not 1. No, not 0. Not 1, but negative 1. Divide by negative 1. You cannot have a negative variable. You have to take your negative with you to the other side. Divide both sides by negative 1. So basically, your sign just gets reversed. X equals negative 15 and a half. Okay? And then if I plugged it back in, there's already a negative. So if I plug in a negative 15 and a half equals 15 and a half, well, what happens to a double negative? It becomes a positive. So it works out. All right, and it checks out. All right, so what you need to know for this one especially is that just an understood 1 goes in front of the variable. All right, and that's it for the multiplication. Now let's talk about division. Okay, so when I'm solving a division equation, well, what's the opposite of division?
Multiplication.
Multiplication. I need to multiply by the reciprocal. Now, what is the reciprocal? Anybody remember what that means? The reciprocal, it's the fraction, but it's flipped. It's switched. So instead of x over 6, I'm going to multiply by 6 over 1. Why do you think 6 over 1 instead of 6 over x?
Because x needs an understood one.
Okay, well, it has an understood 1, yes. And I need to leave x on this side. If I multiply it by 6 over x, my x's will cancel too. I don't want that. I want to leave x by itself. So that's why I multiply by 6 over 1. Whatever number's in your denominator connected to your variable, that's what you multiply by. So if I multiply one side by 6, what do I have to multiply the other side by? 6. So what's 12 times 6? 72. Okay? And if I check it, is it true that 72 divided by 6 is 12? Yep. All right, so I would say 12 equals 12, and it checks out. All right, I want you to try the second one. All right, so now what do I multiply both sides by? Whoa, whoa, whoa. What number is attached to my variable? 12. Multiply both sides by 12. I know it's a little weird because it's backwards. That's why I'm showing you in just different ways how you can see these problems. Because I still have to multiply by whatever number is connected to my variable. Do you see that? You see that, guys? Bruce, do you see that?
So it was just backwards?
It's just backwards. So you could have written it b over 12 equals 14. Then you multiply 14 times 12. And what's 14 times 12?
168.
Okay, 168 equals b, or b equals 168. And then, guys, you would just check it the same way. Okay, now I want to show you a couple other ways that you might see these division equations. Okay, look at the first example. X over negative 5.5 equals negative 36. Now I just have some negatives in there. I even have a decimal. Okay, so but the process is still the same. What do I need to multiply both sides by? Negative 5.5. Okay, keep that negative. Bring the negative with you. Multiply by negative 5.5. Okay, so now x equals, now what's negative 36 times negative 5.5? And you can use your calculators. Negative 36 times negative 5.5. Negative times negative is a positive because there's two negatives. X equals 198. 198. And guys, you can check it again. You can check it just like with the others. 198 divided by negative 5.5. You'd have to probably do this one in your calculator. But if you do negative 198 divided by, or I'm sorry, 198 divided by negative 5.5, you get negative 36. Equals negative 36. So it does still check out. Some of these, you definitely want to have your calculator handy. All right, I want you to see if you can solve that second one. 0.4 equals z over 3. All right, so what do you multiply both sides by?
3.
3. Very good. Multiply both sides by 3 and by 3.
1.2.
Okay, guys, so z equals 1.2.
Yeah.
All right. Okay, you guys are doing really well. All right, now I'm going to solve using the complete reciprocal. Okay, so now I actually have a number in my numerator and my denominator. So I want to make sure I still have to get y by itself. So I have to get the entire fraction of 3/4 to cancel out. What do you think you're going to multiply by? 4 over 3. Now numerator and denominator get canceled. And now you do have to do a little bit of multiplying on the other side. Can you cross-reduce anything?
Yes.
Yeah, you can cross-reduce the 3 and the 12 to 4. And y would equal what? Y equals 16. Now, on your homework tonight, these are going to be kind of a pain to check just because you do have to do a little bit of extra work. But now you do 3/4 times 16, or I'm sorry, times 16 over 1 equals 12. You can cross-reduce to 4, and then 12 equals 12. But you do have to show me a little bit of work on that check. All right, I want you to try the second one. Now, the second one just has a couple negatives, but I'm still solving the same way. I want to see if you can do it. All right, so what did you multiply by to get n by itself? What did you multiply by? Negative 10 over 3. Take that negative with you. Negative 10 over 3. Multiply this side by negative 10 over 3. All right, and now I get n equals negative 50 over 3, or that would be negative 16 and 2/3. Oops, 2/3. Okay, either one. All right, and then, yes, we would check it. But honestly, guys, I'm fine with you just leaving it an improper fraction, because when you plug it back in to check, you're going to have to change it to an improper fraction. So if you do negative 3/10 times negative 50 over 3 to see if it equals negative 5. All right, we're going to reduce this to negative 5, and that'll be negative 15 over 3 equals negative 5. Like I said, these are a little bit more of a pain to check. But yes, negative 5 equals negative 5, and it checks out. Okay, now moving on to example 4. We're going to skip your turn now for now. All right, in example 4, now I'm translating verbal sentences and solving the equation. So I just need to pick apart, I need to find my keywords, and I need to try to write the sentence as an equation and then solve. I want you to go ahead and try the first one. All right, so for the first one, what did you write? Oh, it's right here. Okay, so for the first one, what did you write? 2 what?
2 times n equals negative 100.
Okay, very good. 2n equals negative 100. Then what did you do to solve for n? Divide both sides by 2. Divide both sides by 2. Guys, you're acting like you totally forgot. Like we just did these and you said it was easy. Okay, divide both sides by 2, and then n equals what? Negative 50. And you won't have to check these, but you can just mentally check. 2 times negative 50 is negative 100. What about the second one? Anybody think they know the equation that it would be? Elena? Very good. N divided by negative 2 equals 10. So how do I solve for n? How do I solve for n?
Right.
Multiply by
Negative 2.
multiply both sides by negative 2. Multiply by negative 2, and what does n equal?
5.
Negative, 10 times negative 2. Negative 20. Negative 20. Okay, this is like numbers 34 and 36 on your homework tonight. Okay, one more example and we're done. Your telephone bill lists a call that lasted 20 minutes and cost $2. Write and solve an equation to find out how much you were charged for each minute of the call. So your total, guys, your total was how much? Your total cost? $2. Okay, cost you $2 for the call. And you know that you talked for 20 minutes, but you don't know how much it was per minute. So 20 minutes times how much per minute equals my total cost of $2. That's how I would set up my equation. Then I just solve it. What do I need to divide both sides by?
20.
Divide both sides by 20. And what's 2 divided by 20?
10.
Nope, not 10. 2 divided by 20, guys. Use your calculators. It's not 10. It's 1/10. Or in pennies, that would be 10 cents. 10 cents per minute. Okay? This is similar to a word problem that you'll see tonight on your homework. So basically, on one side of the equation, you have the total cost. On the other side, you have how many minutes times you don't know, or you have your total minutes times you don't know how much it was per minute. So that's what you're finding, the cost per minute. I believe, if you understand that, that's everything you need to know for 7.4.